welcome to Hannover Messe. We are talking this afternoon about AI. And we'll talk especially about AI and the incredible growth of AI and how it actually may apply to operations, right? So focus is on operations in AI, right? We won't talk about, Eric Schaefer had a presentation on AI within products. For this time, we'll focus on how operations can actually leverage AI, okay? So just a quick intro. AI is going through fundamental and incredible growth. And we see over different technologies that they're actually, the growth of AI is picking up incredibly fast, right? And really, it's, I think, why is that, right? Isn't AI bizarre? Isn't it funny? Because basically, AI has been in existence for the past 50, 60 years or so, right? But really, since 2012, it's going through growth of 50% plus over the years, right? And every year it's growing 50, 60%. So I've invited a couple of friends today to talk about those topics, really. And the questions I have for them is, why AI? Yeah? Why AI in operations? What's the purpose of AI? Why AI? What's the difference between AI and analytics and data and management in general, right? Also, we'll talk about why in industrial operations, right? Is it something that actually can be used in operations? Is it ready for operational, 24/7 operations in factories, for example? And to do what, right? So what am I going to do with AI? And then ultimately, we'll also ask, and we've got clients with existing cases coming in to talk about, how they're deploying AI, how they're building their capabilities, and so forth. Okay? So, a few friends to join me. We have Danielle from Microsoft. She's a principal director, data scientist at Microsoft. So, Danielle, please join.
Thank you.
We've got Chris Maddox from Paxata, co-founder and VP of business development. You can tell us later on what Paxata does. And then Greg from Foresia, who's the CDO of Foresia, working on the capability build, AI capability build of Foresia since last year. So, right, welcome. Okay, so I won't go back to my questions, but I think, and maybe we'll start with a short survey on people to see, maybe with your hand, right, and with your fingers from 1 to 5, right? How familiar are you with AI, and how familiar are you with AI cases in operations, right, which is manufacturing, engineering, and so forth? So let's see. Not many hands, but so 4 is familiar, right? Okay. So it's a mixed group, but awesome. I think Danielle, you will start with maybe let's start with the 101 on AI.
Sure. Yeah. You can definitely do that.
And that's the question: why AI?
Sure. So AI is really interesting. We can think of it as the ability to make decisions, to program computers, to understand things. And if you think about it, we really have had that ability for a long time. Like, you can even say a calculator is some basic form of AI. You have lots of numbers, it's calculating them, giving the decisions. But what we really want to do is enable AI to really make more decisions, to help us more. And I think there's been a huge transformation in AI. Back to the point about how AI has really transformed since 2012. We want computers to be able to help us do things that humans also do easily, to be able to perceive, to be able to think, to be able to make decisions. Now, these sorts of things are really hard to program. How do you program a computer to analyze an image? It's very hard, right? We do it naturally. We look around the world around us. I can say how many people are in this room. It's a natural thing for me. I've experienced this throughout my life. But how do we enable computers to do those same sort of tasks, to count the number of people in a room, for instance? And now there's been a lot of advances in the last few years that have come together. And I think there's a few different reasons for this. One is the advances in cloud computing, the ability to really do things a lot cheaper, a lot more accessible than you could before. To be able to both store data really cheaply and then be able to do really a lot of computations on that data. Do computations when you need to, but also only pay for what you need to. So I think that is one really big reason. The other thing is, because of that, There's been a lot of advances in algorithms. Now, these algorithms have actually been around for a really long time, but because there's so much more computing power and more data that you can enable, there's been a lot of advances in research on how to improve those algorithms to make these sort of decisions. To give you an example, in 2012, which is when we started to really see this growth in AI, in 2012, a researcher found out that you could use convolutional neural networks, a type of deep learning, in order to analyze images, classify different images. This was the first time that we saw a huge jump in how machines were actually able to analyze images. And in 2015, Microsoft Research showed how you could use another type of architecture that was actually able to classify images better than a human could. And so in just a few years, these same types of algorithms that have been around for a long time, but because we have so much computing power, so much data available to us, those have really advanced a lot to enable us to do more things. You've probably noticed in your everyday life that there's been a lot of things that just a few years ago didn't really work very well. Speech recognition, for example, on your phone. A few years ago, we all didn't really like it. But now these things are getting so much better. It's because these algorithms that have been enabled through this computing power, cloud computing, and advances in algorithms. So I think those are all really coming together today to really improve AI, and you can do a lot with that. And we've really seen a lot of that same type of technology used in operations, for example.
Great. So I think that's clear now. So it's about why AI, why now, right?
Mm-hmm.
And there's questions about also, is it the right time, right? Because we've been waiting for so long, I guess. All right, it's growing now, but is it the right time for industrials to actually start investing and looking deep into AI? And maybe I'll ask that question to Greg, because as an industrial, Greg is surprised. As an industrial, why are you investing in AI, and why are you building your capabilities now? Because you could wait another 50 years if you wanted. But.
Absolutely, and we'd be dead by then. I think no. So I think if I was here back 3 years ago in Hannover Messe, and everything was about 3D printing. And I like 3D printing because it really shows us, sorry, I have a little bit of Larson here. It shows us, it has the same maturity thing that we're actually applying to AI over here. 3D printing, you have a great new technology. Danielle spoke about really advanced computer research. So we have that in 3D printing. The first thing you do is you take a part and you bring it to your people, and you reproduce the same part. Then the next step is you take that same part and you try to optimize it with a little bit of differences in the part. And then you realize, why am I doing this part? I'm really answering to a value proposition, to a specs, right? And I need to change that. And then you change the part in a totally different way. AI is exactly the same thing. AI is about using data, pushing it through the system, building it into processes, and changing the way you process things, and change the way you are going into, in the way you manufacture things, into a service, into a agile way that is less expensive, that is, in essence, more lean. Mm-hmm. So we're really doing lean. Now, is AI now? Why now? Well, 3 years ago, I know, but I answer. I have my answers. Why AI now? 3 years ago, everybody was about big data, and that's not a coincidence. It takes some time to go from I have data, I connected my machines, to I can actually do stuff with it. I can change my processes. I can, reinvent the way I manufacture things. And the speed at which we're growing, and you still see in Hannover Messe today, tons of companies still proposing IoT devices everywhere, which means the problem is not solved yet, all right? So first, you connect your legacy machines. You get the data. Then you start playing with it. And then at some point, the bigger company comes back and says, hey, you need to integrate the architecture of the company inside. And then you start thinking about, what can I do with my data? How can I optimize my processes? How can I transform this process into a more intelligent way? Now, the first step of AI application is predictive maintenance, as pretty much everybody's been doing for a couple years now. But the next steps are going to bring more evolution. We're going to see more impact on quality, more impact on how we treat things in a very agile and a very contactless way. And that is why AI is so important. AI is so important now because we're getting to have the data. We have the IoT devices. We are really pretty much, not far from getting the right architecture. Now it's all about getting the right software, the right thinking, redesigning the way we conceive and conceptualize manufacturing.
Right, thanks. We talked a lot about data, right? And actually that's a great intro for Chris.
Yeah.
If you could tell us about Paxata, what you guys do and how data is important for AI.
Yeah. Briefly, we built an intelligent information management platform to help comb both devices and traditional legacy systems to be able to bring that data into a usable format. We've talked about data. We've talked about processing, right? And the challenge, one of the reasons why we saw major growth in 2012 and 2013 is now we're actually collecting the data that's coming not only from our internal organizational systems like our SAP environments, our financial systems and the like, but we're now also grabbing all that IoT data, right? So the complexity and the diversity of our data has gone off the roof. In fact, we're collecting data and we have no idea what we want to do with it quite yet. So at Paxata, we believe that you actually, in order to have AI, you need IA, which is an information architecture. And I think over the last 4 years or so, we've been building that information architecture. But the key is, while Microsoft and Accenture have a lot of data scientists, Greg doesn't have that many. And you can't hire them fast enough. And so how do you actually take the data that you have and make it available to the broader number of information workers within the organization? And through that, then you can enable more AI. You can enable more automated processing. And that's what we've actually worked with companies like yours and obviously with Microsoft, running on Microsoft, and working with Accenture to be able to help companies to accelerate that process of finding the data that they need, turning it into usable information. Because data on its own is incomplete, it's inconsistent, it's found in multiple locations, there's different nomenclatures and semantics that are around that data, so you need to normalize that very, very quickly, put it into the hands of people who understand it, and then feed it into your machines. Feed it into your AI, feed it into your machine learning algorithms. If you're feeding inconsistent, it's like analytics was 10 years ago, 5 years ago. If you're feeding inconsistent and incorrect data into those frameworks, your outcome's not going to be good.
Totally.
Right. Thanks for that. So we talk about why now, the importance of data, and so forth. So how about, can you give us concrete examples of usage of AI? And let's talk about operations, right? In ideally industries.
Sure. I can give a couple examples. So we're working with Jabil Manufacturing. They're manufacturing circuit boards for a number of their end companies. So one example is they actually want to do two things. One is they want to improve quality along the manufacturing line. And the other thing is they want to prevent failures later down the manufacturing line. So to give one example of this, they have an automated optical inspection machine that takes pictures of the circuit boards as they're being manufactured. So there's lots of different components on that circuit board, and the operators today look over all of the different components to see which ones are defective or not defective. There's some basic logic in that optical inspection machine, but the operators look over lots of things. We want to speed how they're doing this up. So these operators, we want them to focus only on the defects. So what we do is we use algorithms running on the Azure Cloud Computing Platform in order to actually automatically identify which components are faulty or not. Now you might be saying, how the heck do you do that? That sounds crazy complicated. How we do this is we actually just collect a lot of data. Data is really the key part here. We have lots of historical information. These operators have labeled this data These ones are faulty examples. These ones are non-faulty examples. And then we give those examples to a machine to learn from. So that machine needs that really good quality, cleaned up data set that's annotated that it can then build a model on. And then that model can then generalize to new circuit boards or components that are manufactured. So we're using that in order to improve quality on the manufacturing line. As another example of running machine learning, actually this time on the edge, we're working with Schneider Electric, who is actually has these oil pumps that are running, and they actually want to determine whether those are working correctly or not. So we also have a machine learning model. This time we deploy that on the edge device in these environments that really cannot be connected to the internet all the time in order to actually understand when something is going to fail in the future. So those are two examples.
Great. And so, because I mean, they sound like great examples, but how do you go about, and maybe that's a question for Greg, so how do you go about actually capturing those, right? What's the process for going from, okay, I've got this idea of how I could use machine learning into, all right, let me build up a team, connect with Microsoft, whoever, to actually put this in place. How does that work? How do you do it?
So there's many ways of answering your questions, but I think all in all, the issue with AI is that the field is so vast that you can do tons of things, right? And one could be tempted to just jump on everything that sounds really cool. Reality is that you have to understand where is the best output you can actually get. And the only way to do that is, of course, being very intelligent yourself with your teams, but also being really connected with other people outside your teams who are and outside your companies who are very intelligent too, and who have been trying stuff. The best way to optimize your process and to rethink how you produce is actually probably not sitting in your company. It's actually probably sitting in another company, maybe not in the same industry. So gathering into ecosystems that go into that deliver new ideas, that show you how to think about the concepts, and then in that same ecosystems, putting in place those who know, like you, to make it happen and get the speed that's essential. Again, speed is very important. If you don't deliver in a new concept very quickly, nobody really believes in it. So you need to bring this ecosystem in a close way and to work closely with your partners to deliver.
Right, and Chris, any example on your side of how you've applied data preparations in operations?
We do. There's a large device manufacturer overseas that I can't mention their name, but they basically have connected devices, and they're able to actually grab data from those connected devices, data from if something's malfunctioning, why does it malfunction? To what are the things that people are doing with this device? What do they want to do? Where are they failing? Where are they spending the majority of their time? So it's two things. One is ensuring that they can actually improve the manufacturing quality of the products that they're providing to market. And second, which is probably the most important and big leapfrog for them, is how can I create new services and new capabilities based upon the interaction of my customers? Not just based upon a guess or trying to talk to a handful of people, but actually a broad set of individuals, again, data, being able to bring that and assess that data and identify where there's opportunities for new services and new capabilities within those devices.
Great, thank you. And I should have said that at the beginning, but you guys can stop us anytime and start asking questions on the particular topic that we're discussing, right? So don't hesitate. We've got microphones, I think, or Gemma, you've got them, right? So just please raise your hand if you've got a question, and we'll take it. Max, you've got a question?
Yeah, one question. What is, according to you, the most insightful application of AI you have ever seen so far?
Sorry.
You stole my question because I had that one.
So you repeat it.
Yeah, and actually, I think that's a very good question. So let's maybe take a quick poll of our guests here and see, and let's take out predictive maintenance, because we see predictive maintenance and using AI everywhere. So you cannot say predictive maintenance. What are the what is the top application of AI that you see within industry, maybe of what you've seen around at HMI, or what you foresee that will come over the next year or so? What's the top?
So as a founder of a software company, everything that we do is actually based on AI. So we took the problem of data diversity within an organization that typically you need someone who's very technical to be able to actually identify the structure of the data, join the data together, clean the data, leveraging various ETL techniques or the like. Yet we actually felt that AI and machine learning could be applied to make that process extremely simple for a business analyst, someone who understands Excel quite well, but they don't actually understand what a Cartesian join is or an inner and outer join. So we actually leveraged that AI back in 2013, and because of the processing in the cloud, we're able to actually provide that capability at a much lower cost point. So as a founder, I'm just going to leverage
So it's using AI for your own product to make it smarter and data preparation smarter than what you could do in Excel.
Exactly.
And so forth. Right, okay. That's one
I think
answer.
that's a great one. AI for AI.
Yes.
I love it.
It's an infinite loop. Like
Yeah,
this.
that's great. Yeah. I'd say one area that I think hasn't totally hit off yet, but I think is super exciting, is the area of chatbots, to be able to really accelerate how people interact with things, make them faster. I think it's going to be very similar to when we first started with speech recognition on devices. Wasn't really that great. A lot of the bots that we interact with today are just okay, but I think that field and that area is going to take off tremendously and help all of us. Not just help companies be more efficient in human resources and customer service, but also help us get the answers faster. Like speaking to your HR, you have a question about something. Sometimes that stuff takes a long time, right? You want an answer right away. So I think that area is an area very impactful to our everyday lives that I'm excited to see.
So chatbots and maybe how you can actually use chatbots in operations, right? Operators on the line, how they can actually talk to Cortana, for example, to request support.
As one example, there's been a lot of progress in just the last few months on document summarization and the ability to answer questions. So to be able to take a manual, for instance, on how to actually work with an object or work with something and get the answer of how to work with it, thumbing through a manual, trying to find the right information. We have algorithms that are able to summarize and gather answers to questions as good or better than a human today. So those are the types of things I think are going to really help humans do more with our time, because we don't have enough time. Right. So I think AI can really help there.
Greg, what's your top?
We're working right now on a product that kind of like goes back to what you said both. It's a smart guidance product. And I like it because it's going to incorporate different capabilities, AI capabilities. Potentially, smart bots is going to come in a second step to enhance the knowledge management and diffuse this. The really important thing is it goes back to your point. AI is really super powerful when people know how to use it, and when you make it really concrete for them. So I like this smart guidance project because it brings AI to the shop floor, to the normal people, and it empowers them to be master of AI and then to think about what are the next steps, what are really the specs, and how to change things.
Great, thank you. Any other questions right now? Or? All right, so we'll take another one in a minute. So thanks, Max, for the question. All right, let's talk about the capabilities that you need, right, within your organization or outside of your organization, actually, to do AI, right? And what are so capabilities and maybe best practices? The top 5 things that you would do to not. And this is not about piloting or doing proof of concept in AI, right? It's really embedding AI within your processes, and how do you make it industrial and so forth. So what are the capabilities that you need for that?
So I'd say one thing is, obviously you need a data science team. People jump to that right away. But I think almost more importantly that people undervalue is really knowing things like knowing what your data is, knowing how that data was actually generated, the assumptions behind that data generating process, knowing the domain really well, not creating an isolated data science team that's going to go do AI in the corner, but really embedding them within the organizations that know what they're trying to solve. We actually, one of the most important things I think in an AI project is not so much about the specifics of the AI, but what problem are you trying to solve? And even before you start doing the AI, how would you use the answer? So thinking about the end-to-end loop. You don't want to go into proof of concept and say, oh, it'd be so cool if I could predict this thing, and then spend 6 months building a data science team, figuring out you can actually predict it, and then realizing, oh, you know what, I can't even use that prediction because I need to order 6 months in advance my parts, and so even if I knew what parts I needed, I'm not predicting far enough in advance. So thinking about how you're going to use that answer and then embedding data science within the business, I think is very important.
So thinking about a business problem to resolve that you really need AI for, and embedding your data science team within the business or actually connecting very closely with the business. Right?
Yeah, quite connected with that is this notion of iteration and agility. Don't be afraid to actually follow the data. The data will actually start pointing you in a particular direction, and it's important to actually know that whatever your perception is coming into it may not be actually the result that you expect. So spend that time around iteration in an exploratory way, and a lot of the frameworks that are being built today is that design, is being able to quickly iterate and follow the data down a path, and it may take you down a path that you didn't expect.
Totally agree with both of you again. What can I say? It took
capabilities.
It took some years for us to connect the machines, get some data, and start bringing some value to that, and we're getting there. I think going back to your point, using data scientists, connecting them with the teams, making sure you treat the right problems, but also doing it in a way that you deliver quickly and put enough means on it. Because you want to go for big, you want to go for money, you want to go for value, not technical. You want to go for value, you want to go for big and quickly. And that is essential because it demonstrates to the rest of the company that you can do things, that AI is really cool, that you should go and ask for more. So I would say, make sure your data consistency is where at the right level because, as you said, pour data in, pour data out, and then work with the teams on the shop floor to redefine what you actually want to do and track the savings. Ensure that you have this vision of what you're delivering for the company and how AI is actually a transforming vector for your company strategy.
And how do you embed your data scientist team with the business really? How do you do that? And how how do you bring them up to speed on the AI topic?
So for us, clearly at first we didn't need an internal data scientist team because, as we said, first you get the data, and before you get the data, you don't need a data scientist team. And then when we started wanted to play with the data, we used external resources. And we're still doing so. We're building an AI team right now, which is going to be, for us, quite extensive. But we're embodying that team in, I like to think about it, a 3-layer cake, right? The first and most important is connect the team with the business. So all my guys, they're going to go 1 month in their plants and on the shop floor to understand what's happening. And that's an AI person. It's like they play computers and everything, not injection plants, injection machines with trolleys and carry things. So really not manufacturing. So it's important to know what people are doing. It's important to be connected to the business. Second thing, we have a partnership with Accenture. And so we embodied our data scientist team in the Accenture offices so we can ensure that the level of our team is actually the same pretty much. So I don't have to, I'll have specialties, right, obviously, but I still bring the capabilities in a scaled way with the right level, and that's super important, especially if you want to go to scalability. I don't want to, have PhDs doing another PhD thesis. I want people who actually deliver in a consistent way. And the third layer of the cake is still data scientists want to be in sync with the next thing that's going to happen. And that is also what we're doing. So with our partnership with Prairie, we are going to make sure that we're going to be in touch with the latest and newest in those very siloed deep learning algorithms, so that if we need them, we can use them. And by doing so, the first layer, we connect to the business. The second layer, we ensure scalability. And third layer, we ensure excellence. I think that's a good recipe. I hope it's a good recipe.
And that's a good point around also what I think is amazing about AI and the models that we're building is how quickly they progress and improve, and actually how you must always sort of rethink the technology you're using, the sort of models that you're using. So how do you keep up with all that, right? Because you mentioned your example about image recognition in 2012 and versus the one in 2015 that was totally improved, right?
Yeah.
And so as a system integrator, we used to put system in place, and you just install them. 10 years down the road, you maybe do an upgrade and so forth. But AI is different, right? It seems like you really want to. It's a sort of ever-evolving solution. So how do you do that? How do you keep up with that?
One thing that I think is really great about the AI community is it's really open source. There's lots of things in the community that you can leverage and build upon. On the Microsoft AI platform, for example, you can leverage all of the great advances that are happening in that community and then build on top of them. So I think you stay on top of them by leveraging and seeing what other people are doing and building off of that. It's amazing what is out in the open today, and you can even there's lots of open courses on AI. Microsoft has a professional degree in artificial intelligence, for example, that's an online course. So I think those are the types of things that you can do to stay on top of it, and I love how much is open and available for people to leverage and learn.
I was going to add also, free up your data scientists. Give them an opportunity to go actually explore. The challenge that we've seen, I'm sure you've seen this in your business, is the data scientist teams, they spend all their time just working for the business analyst group on just standard analytics processing. Right, so free them up, enable the business to be able. We've heard self-service analytics for the last 5-7 years. Give them the ability to actually do that, so the data science team could go explore, so they can go spend their time actually re-educating themselves on some of the capabilities that are out there, and then give them the tools. The nice thing about cloud architectures is you can very easily spin up an environment and give them a chance to go test. Go play around with things. So it's really important to provide them the ability to do this. Don't just give them a data science title, but actually give them the capability as well.
And that's a great example, because I was going to mention that. I remember, I think it was this week or last week, we had one of your data scientists, Greg, join the team, and his first thing was, all right, I got this computer. This is the corporate standard, and I don't have the admin password, right? So he couldn't install anything. So he had Excel, Word, and PowerPoint, great products, by the way. But still, he couldn't do any AI because everything was, you had to install it. And so the whole point around freeing up your data scientists so they can actually use their own tool, research, go for open sources when needed and so forth, I think is absolutely critical.
And it's been solved in one day.
We fixed the issue. But,
totally. No,
Chris, Greg, you were going to add something?
No, I totally agree. I mean, again, going back to my three-layer cake, the top layer is necessary. You can't be creative. You can't think out of the box if you don't have this little space for you to find what is best outside and apply that. And if you don't find that, you don't bring the top creativity with the top value to the business, and they're not happy, and you're not happy. So you really want to be able to go forward and find those things and play with smaller companies, play with other industries, play with your partners everywhere, because they bring you stuff that you would take 5 hours to find, and they give you the 2 seconds answer.
Right.
And frankly, the data science community is
very open.
And they're going to go find their space somewhere else if you don't provide it for them. So we talk to a lot of companies that are frustrated because they spent the last 2 years educating these data scientists, and then all of a sudden they go somewhere else because they didn't get that flexibility and freedom to go actually explore and actually design. So you need to give them that space.
And to be also, to bounce back on this, I work in the automobile manufacturing industry. Our cycle time for products are 3 years, 3.5 years, right? People have this cycle time in their head. Digital, and we've been doing digital for the past 2-3 years, 3-4 years now. Digital has changed a little bit of this, thinking about what's the real cycle time for some of the product that enhance your capabilities on the shop floor, to try to reduce it to like maybe 2 years. AI is going to be even shorter than that. Mm-hmm. So you have to be prepared to do that. You have to really not fear of changing your products, really putting stuff in the garbage and upgrading to something else, because that's what's going to bring the value. And there is also a change in mentalities that you need to, put in place from the clients all the way to your guys.
So agility as well. Right.
Absolutely.
Great. So I think we have a question there, right?
Yes, actually, we're still in the middle of it right now. So you were talking about the data scientists a lot, and actually that kind of sounds like a bit of a generic concept to me, because, or I'd like to have your view on what makes a good data scientist. Do I need someone to have statistical knowledge? Do I need someone with tool knowledge or whatever? Because many of the organizations that we're dealing with, and probably the people here, are looking for data scientists, but what exactly am I looking for? What's your view on that?
And you may have multiple profiles, right? Because I know
I
that
was just gonna
within
say
our team, we bring different profiles. I mean, we've got,
Yeah, I was just going to say there's a famous diagram by Drew Conway about how you need multiple things like statistics, computer science, domain knowledge, all of those. I think the key is often one person doesn't have them all. So you need somebody on the team that has the statistical background, people who can do really great computer programming, and then people who might have the statistical background in a certain domain. So I think you do need to balance and complement the team, because you're never going to find that person who has everything. You will search forever and you just won't find them. You might be trying to find a data scientist who has that expertise in your domain and they just aren't around. But if you find somebody who has maybe an analyst background but it knows the domain very well, who can work alongside somebody who has the deep statistical knowledge or the deep computer programming knowledge. So I think you need to not look for one data scientist, but a team that can together has that complement of statistical, computer science, domain expertise that together can solve a problem.
And we, with our projects, actually, we typically have minimum teams of 4 to 5 people, right? So we have really 4 different profiles that we include in the team. So do you want to expand on that, Chris and Greg? Or?
Well, just from our perspective, we hire a lot of data scientists as we develop our product, but we do team programming. Because not one, like you said, not one individual is going to actually have everything. We would never be able to hire anyone if that's the case. So I do believe it is actually setting up the team appropriately, not an individual, but it's having that diversity in the organization. And to your point, I think bringing in the business can actually help you bring that domain expertise and understanding, especially because a lot of our business analysts, they have 10, 15 years experience in our business, and they've seen what's worked in the past and what hasn't. A lot of the data scientist individuals that we're bringing up, they don't have that deep domain expertise. So by pairing them together, I think you're going to get a better outcome.
Another question, Gemma?
Yeah, we've got one from Facebook, so coming in. What's the best AI platform?
Ooh.
Very contentious, and also
I feel like
Danielle,
I have to not answer.
I know, and also related, roughly price-wise, what's the cost?
Oh, what's the cost of an AI platform?
Yeah. So what's the best one? Agree, you can't.
So I'm going to give the very biased answer of the Microsoft AI platform, and I'll let other folks talk. But I think that one of the great things about cloud computing is the costs are really dependent on what you need, and you only pay for the things that you need. And you can even spin them up and down over time. So for example, that deep learning solution that I was mentioning earlier, trying to analyze images along the manufacturing floor for quality assurance, we can spin up GPUs to train a really large deep learning network and then turn the GPUs off and never pay for them again. So I think that's one really great thing about any kind of cloud platform is paying for things only when you need them, and then devising an architecture around that.
So the answer on cost is from €0 or €1 to
very dependent on what you're trying to do.
Well, and the speed at which you could do that. That's extremely important, right? We've been in customer implementations where it's on premise, and it takes us 6, 7, 8 months just to actually find the hardware to do the install. We're not going to move very fast. So if you have an infrastructure that you can spin up and spin down very quickly, it's going to give you that flexibility. And second, which I think is most important, is what's the value? To your point, is what is the value you're trying to drive from the process? It doesn't, I'm not going to say this, it doesn't matter the cost, but if you're actually driving the value from it, the price point at which you're actually going to pay, you'll be able to actually justify that in the end.
But I guess to go back to the platform question, right? There's a, and we talked briefly about open source, right? And it seems like actually everybody and all the GAFAs and the Microsofts are all working actually on platforms, openly and sharing really the knowledge that they're building around AI. So do you see that trend continuing?
Absolutely. So I think open source technology is super important and fundamental, and I think a lot of companies, Microsoft included, are working on how can we enhance that, provide services that allow you to do things flexible in a faster way, and then are reliable for production-like environments. How do we stand up this deep learning model to run all the time at a very low latency so that I can depend upon it? And those are the types of decisions and reasons why you'd move to a cloud computing type of platform.
Right.
I think, to go back to the answer that was, to the question that was asked, I think the AI platforms none of them is good enough, and they're all evolving right now. I think that's why we're playing with several players, because we need to grow the right one, and I don't think there's a mature, I don't think we have the endpoint to that.
Is this a question on ecosystem then, bringing it in?
No, not necessarily. I think that's why we're working with you guys, because you have a great solution. I think we're also working with you guys because you have another part of the equation, but the full spectrum, nobody's really pinpointed it fully down. And I think, that is it's a maturing issue, which also prevents us also from answering the question of cost, knowing that it's always too expensive.
Well, I think the reality is that there's never one size fits all.
Yeah.
There never has been for the enterprise. The important part is, to your point, is the ecosystem is actually working very closely together, and open source has made that happen. Other technologies like GitHub and Apache Spark and other things like that have allowed us to be able to share this information in our learnings across the community.
Great. So we'll take questions from the crowd. I'll ask one last question, because we started to talk about talent, right? And so I've got questions for you. So how do you, especially as industrials, right? I'm an industrial company. How do I hire data scientists, right? I guess most data scientists want to work for Google, Microsoft, Amazon. How, as an industrial company, how do I get the right talents within my organization? How do I attract them, right? That's one. And especially, how do I keep them afterwards, right? How do I create this culture so they actually stay? It's more than just a hire, right? And so I'll be interested to hear your opinion on this. And Danielle, it's probably easy for you to hire people, but how do you see your client do that, right? How do you
I think it goes
right
back to the points raised earlier of giving data scientists freedom to create value and see how they can impact the business. I think one of the most important things for data scientists, and for, frankly, lots of people, is to see their work having influence and having impact and translating to things that are real. So what I was mentioning earlier, don't putting data scientists just in this isolated environment, but actually embedding them within the team so that they can create value and see how they're influencing. I think that's very important.
Yeah, and I think what you'll find in that process is you already have a lot of data scientists or those that have capabilities to become a data scientist within your organization today. So have those conversations, and there's a lot of very hungry individuals out there that are constantly trying to learn and constantly trying to actually upgrade their own capability, their own net worth, not within your organization alone, but also in the community as a whole. So look inside your organization and make assessments of those individuals that are actually trying to become data scientists as well.
And I would say, if you are a data scientist and you want a job, come and join us. Start working with Microsoft. And afterwards, what I think is also interesting is people, as you said, they don't just work on data science because it's fun. They all work on data science to change the world. So if you come and join us, you'll be able to. If you come and join us, you'll be able to play with manufacturing and change the way we operate 270 plants. But you're also going to be able to change the way we operate the inside of the vehicle, the mobility, how you bring cognitive to inside a cockpit. And the promise that I give to my data scientists, to answer your question, and that's why some of them are coming, is I don't let them only play on the manufacturing side. They also go and play with cool HMI and inside predictive cockpit stuff. And that is very valuable for them. They can take part in the elaboration of tomorrow, into the sustainability of our companies and our world. And I think this is very important.
So that's how you keep them also engaged with the organization, is to continuously challenge them, get them to work on new topics, concrete stuff, manufacturing, but also autonomous vehicles, autonomous cockpits, and things like this. So, all right, interesting. Okay, good. So now we'll take questions from the room. We've got one here, right here.
I work for French Railways, and we work on predictive maintenance for a long time, and we are pretty deceptive about what big data can provide on predictive maintenance compared to what an agile analytics provide. Do you have a lot of use case, industrial use case about predictive maintenance?
So by deceptive, you mean you're disappointed, right?
You don't have the clue yet.
Oh, okay, so you're not disappointed. You're just you don't have a clue yet. All right, so question on predictive maintenance.
Yeah, predictive maintenance is a really tough area because you need to make sure that you're collecting the right relevant data to answer the question, and that the data is relevant enough that it could be predictive. So we have seen some companies who want to predict something, but the reason why things go wrong are things that are just simply not predictable. A human comes in and bashes, you want to predict when this door is going to fail. And it doesn't fail because of any sensor reading that you can get or any degradation over time. Those are the things that predictive maintenance could, but some human just comes and bashes it. That's not a very predictable occurrence. So I think you have to capture the right relevant data, and that's where connecting data scientists with the domain experts, the maintenance folks who know what is that relevant data, capture those data points that are things like degradation over time in those sensor readings, things like that. Those are the types of data points that can be used to do predictive maintenance. So it is a tough field. It's not just this magical thing of you throw in lots of numbers, you're going to get a model that predicts things well in the future. But I think you also do have to think about the value. Sometimes creating, in these kinds of fields, creating a model that it's better than chance, but it's not 90% accuracy or whatever number. But if it's better than chance and you can rank what the maintenance workers are going to go look at, I mean, that could be tremendously valuable, even just that rank ordering of which machines to go look at or what thing you want to go do. So even sometimes just that little added value of the model can actually be tremendous value. So you also have to think about how do you evaluate the model and think about the value translation. But it is definitely a tough space to go into.
I think to add to that, I think you have to think about exactly what you said, the value. Everybody spoke about predictive maintenance, and I think it's a question about pushing your company into a data-driven, manufacturing mindset. So the goal is not necessarily to get all the tons of millions from predictive maintenance, like the core, AI technology. But as you actually do this, you find value just applying SPC, applying, standard quality on stuff, on machines you actually didn't look anymore in the past. I also think it pushes the company in a way where we are more data-driven and we understand better the value next to it. So the goal is not necessarily to attack predictive maintenance. The goal is to understand you can play with data, you can put AI on it, but then what's your next step? What do you put on the side with other processes that increase your value and your value space on manufacturing as a whole? So I think it's also a cultural change.
Great. Any other question? We got two over there.
Yeah, I'm more coming from the just out of university direction.
You want to work for Greg, right?
I am the kind of data scientist you're looking for, but
I am happy to hear so.
but
Bring me your resume.
Being interested in like what is the data scientist's role is for me right now. Like how will AI develop? Like what will be the next? What will be the thing we are looking at in 3 years? You mentioned the back 3 years, big data in 3 years. And I think predictive maintenance is a really nice example to go by, maybe in the direction of self-regulation, self-organization. Are we trying to replace like everything in the company, or are we just trying to solve some problems, like you mentioned earlier, reduce some time? And then maybe as a follow-up question, just right away, will the data scientist become like the manager who manages the different AIs working instead of a team? He just has AIs. Is that where the data scientist role will go then?
So I can start on that.
Yeah.
I think first on the second part of your question, I think as we said earlier, there are different parts of AI experts and data science, and you will have the guys who actually go in the forefront of what's new and bring in the new innovations, because their quality as human beings is to be very creative. And some people will be a little bit less creative and a little bit more, into managing the algorithms and making sure that they adapt to different temperatures, conditions, whatever. And those guys will be the management of the algorithms that you actually put. And you're not going to be employing them in the same places, in the same geographies. I think, so that's a first answer. Your first question was what?
Basically, what we see in 3 years.
Oh,
long term.
I have every year I have a discussion with my management about budget. That's a very scary discussion, because they're like, okay, I need to know exactly what you're going to do in the next semester and the semester after that. Give me your projects and everything. So here's the way I manage things. I think about Plato. So you remember Plato's idea. So I think about, dark plans. I think about really advanced concepts, and I push the full company towards this. But I know we must not achieve that. It's not a good thing to achieve that. What we really want to do is go on the path and make sure that we have people delivering the right projects and the center of AI again. And as we do so, the more we step forward, the more we understand what we're doing. So every 6 months, every year and a half, I see potential new capabilities we can actually implement as pilots that will actually deploy in the rest of the 270 plants across. Deployment takes more time than piloting, so there is a span to
so it's
the full value.
keeping it agile, right?
Exactly.
Because in 3 years from now, it's difficult to predict, but
exactly. So what you want to do is really think about, what's your idea in the end, what are your short-term idea, and how you bring the value. And let's just play from there.
All right. Thanks for that question. You could send your resume to
absolutely
to Greg
and your friends.
You mentioned data-driven company or something like that a little bit earlier, and that's something I want to ask your thought about. I'm a data scientist. I have a job. Thank you. But we try to do projects. We try to embed with the company, try to understand what they're doing, try to have decision maker right from the beginning. But sometimes we struggle to have them use the tool, have them use what we've done, and have them understand that it's not just a one-time thing. It's something that they can work with. Mm-hmm. So do you have any thoughts or idea of example, or how can we help to have a more data-driven company?
I'll take a first step of this. I think the first step for the most organizations that we spent time with is to have this guy, to have a chief data officer, someone from the executive team that actually will drive the change within the organization, because that's the number one issue. Right? You guys are creating great opportunities for process improvement, for increased value, for even products that you've never developed before. But if you don't have a senior leader within the organization saying, we need to change the process, it'll never be implemented in a meaningful way. So job security for you. But it's true. We've also seen the change and you guys have seen this, the change in the chief data officer or that type of a role move from an operational underneath the CIO or others into sitting at the executive committee, reporting directly into the CEO or the COO in some cases, depends upon the organization, because of the importance that that making sure that whatever data-driven decisions we're trying to drive the organization down, it comes from the top.
And also what we do for most of our digital projects so I mentioned that we had a team of data scientists, right? We have 3-4 different types of data scientists within projects or product developments, right? What we make sure is that the product itself is owned by the business, right? And they are embedded from the beginning, right? So typically the product owner and the co-product owners are actually from the beginning within the development of the product, right? So there's no we don't do change management anymore. You know, that you develop a product and at the end you're like, all right, let's go to the business and you got to use this and so forth, right? It's really making sure the business is engaged from the beginning as a product owner in the development of the product, in the development of the AI models, actually, you know, and that actually at the end you don't need to do any change management because this is just part of the development of the product. So I think maybe with your organization, it's all about making sure that you don't work in silos and that you bring the business along the journey and not just at the end for change management.
And I think the more things you can give people to play with rather than here's a presentation on what the model results are and people will say, I have no idea what a recall of a model is. Why are you telling me about these numbers? But if you can give them a tool where they can play with it and throw in some numbers or upload a picture or whatever is the thing that you're trying to use, if they can play with it and see the outcome and actually say, oh, I actually believe this is actually can be real, then they can feel it more and give more meaningful feedback as well.
I totally agree. I mean, it's all about value with the business. And by the way, sometimes you fail. So sometimes what you try to do is just a bad idea and you kill it. So, you know, it's part of the evolution which we talked about and the creativity. Not every idea is a good one, even when it comes from the business, by the way.
Right. Do we have time for a last one or one more? One more, please. One more. Oh, right here. Oh, yes, right here. Last question. Thank you.
Oops, sorry. Yeah. Sit back down. Okay. Just alluding back to you were saying like giving something to the customer so they can play with it. Do you have any tips and tricks? I think I've encountered issues where the first time we're presenting results, the customers are kind of like, I don't believe it. What does this mean? How do you prove it? And then we kind of stumbled in our first customer engagements. How do you guys make those success? Do you have any like approaches or recommendations how to improve that first time where people are kind of skeptical, kind of especially in the industrial world? I think a little bit more traditional sometimes, some of the organizations. So it seems like a big step sometimes, and we find ourselves struggling in those first miles, I'd say.
Yeah, what I'd say is the more examples you can get from them, that how they explain things in their words, and using how they explain things, and then embedding AI within that, rather than translating it all to how a data scientist or a business analyst organization thinks about things and saying it back in their words. So rather than, you know, I have a 90% recall of thinking about, oh, your operators will save half of their time. So as much translation into how they think, thinking from their perspective and how they speak about their business processes, and then giving them things to play with where they can see that it's real is very helpful.
I see it's no different than analytics. When you build out an analytical dashboard for an executive or a senior level person, you hand them the dashboard, and as soon as they don't recognize something in that data or that analytics, they toss it, and then they go by gut. So walking them through that journey of where you started, what you've done to get to where you are is also important. So we talk a lot about data lineage. How do you actually find the data sets or the data that you're leveraging to actually create the predictions or create the model that you're running? Will give them better confidence that, okay, maybe the data is actually telling me something I didn't expect.
And going back to the KPI, again, you both are right. For us, it's about being quick and showing the money. If you don't show the money, people don't trust you because they'll think, hey, it's like taking too much of my time. It's really fun and sexy and everything, but all in all, it's not sustainable. So I'm going to go and do this more traditional thing, which is certain to bring value. We want to show, and we need to show, there is financial impact in all of those digital and AI technologies that we deploy. Because if you don't bring in the spark, you don't bring in the sustainability, you don't bring the engagement of the teams.
So, and I was talking about the AI teams that we typically have, right? So within your data scientist team, make sure that you've got one that's actually quite good at communicating, right? And making it simple for the business to understand what you guys are talking about, right? So I do spend quite a bit of my time actually reviewing projects like the one you mentioned to say, okay, what are we trying to say and what's the story? Storytelling is very important. So if you've got one guy within your team that will tell the story, just make sure that you've got one of those involved. All right, so great. Well, thanks for your questions and participation today, and I hope this was of interest. So don't hesitate if you've got any other questions after the Facebook Live broadcast.
Thank you.
Thank you. Thank you.